Today's lesson we're going to talk about polygons and what their angles add up to. So first let's talk about what a polygon is. Okay, a couple things. Polygons have to have straight sides. They have to be completely closed, and you can't have sides that like intersect each other than at the vertex. Okay, so I'll just say no intersections. Okay, so looking at these three examples here, uh, this first example, that would be a polygon, okay, because all the sides are straight, all right, it's closed, and none of the sides are intersecting each other than at each vertex, all right? So the way we name a polygon is we determine what type it is first, and then we are going to travel around it using the letters. So for instance, this one has 1, 2, 3, 4, 5 sides. So this will be pentagon, and then I can just name the letters A, B, C, D, E. All right, the next example here, this one is not a polygon because, well, it's open right here. All right, it's not a polygon. And then the third one is not a polygon because side AE and side DC intersect each other right here. All right, so this is actually two different polygons. So this one's not. All right, so we talked briefly about naming polygons. So let's go through all the different types of polygons there are, depending on the number of sides. So if there are 3 sides, we are pretty familiar with this one. This is a triangle. 4 sides would be a quadrilateral. Right? 5 sides would be a pentagon. 6 sides would be a hexagon. The one that's not on there, I'll slide it in here. 7 sides is a heptagon. Okay, 8 sides is an octagon. 9 sides is called a nonagon. 10 sides is a decagon. 12 sides is called a dodecagon. And anything above 12, we just call it whatever number it is. Let's say it had 28 sides, it would be a 28gon. So n represents any other number we don't have a name for. So that would be an n-gon, an 11gon, a 14gon. Okay, so let's name this one right here. This has 1, 2, 3, 4, 5, 6 sides. So this would be hexagon, and then just, you can go clockwise or counterclockwise, but don't jump across. So we'll just name this hexagon B, D, H, K, M, G. And that's how you name polygons. Okay? Okay, a convex polygon, all right, is a polygon where none of the sides are really caved in, okay? That was pretty bad drawing. Let's see if I can undo that. Let me just do a triangle. That's a little easier. Okay? A concave polygon means it has like 2 of the sides would be kind of caved in, okay? Concave, to help me remember that, I always say it's caved in. So that's a polygon, but it's caved in, so it's concave, okay? And a regular polygon is when all the sides are congruent and all the angles are congruent. Okay, so we have a couple of examples here. It says classify each polygon by its sides and identify if it's convex or concave. All right, so this first one here, let's see, is 1, 2, 3, 4, 5, 6 sides. All right, so this is a hexagon. All right, none of the sides are caved in, so this is what we call convex. Okay, let's go to the next one. This one has 1, 2, 3, 4, 5, 6, 7, 8 sides. So this is an octagon, and it is caved in right here, so this would be concave. All right, now we all know that in previous lessons, triangles, the angles of a triangle always add up to 180. Now, to get that, there is a formula, and it's this formula right here, okay? So what we're going to do is basically we're going to take the number of sides the shape has. We're going to subtract 2 from that, and then multiply it by 180 degrees to get what the angles all add up to, okay? So as an example, a triangle has 3 sides. So if I went 3 minus 2 times 180, that's 1 times 180 would be 180 degrees. Okay, so let's try an example here. It says find the sum of the measures of all the angles of a 15gon. Okay, so 15 would be my n. I'm going to plug into the formula, n minus 2 times 180. So this is going to be 15 minus 2 times 180. All right, that simplifies out to be 13 times 180. And when you calculate that out, you end up getting 2,340 degrees. So a shape with 15 sides, no matter what it looks like, if it's got 15 sides, all of its interior angles are going to add up to 2,340 degrees. Let's try another example. All right, in this example it says find the measure of angle y in the pentagon TVYMR at the right. Okay, so I'm looking for this angle right here. Now, first thing I need to do is figure out what all of these angles add up to. All right, so again, n minus 2 times 180. All right, pentagon has 5 sides, so it's going to be 5 minus 2 times 180. So that's 3 times 180 to get the sum of the measures of all of those angles inside. If you do that right, we get 540. Now, all right, it gives us a bunch of these angles. These are all 90 degrees, okay? And I know this one's 135. So to figure out the missing angle, what I'm going to do is I'm going to add up all of these angles first, and I'm going to subtract it from 180. All right? Let me do my math here. All right, so when we add up all these given angles, you get 405. Now when we subtract that from 540, the missing angle would be 135 degrees. So that's how we use the polygon angle sum theorem. Okay, our next concept is going to talk about the exterior angle sum theorem. Okay, if you take any polygon and you extend its sides in the same direction, it creates exterior angles. Now, no matter what shape you have, the sum of the exterior angles of any polygon is always 360 degrees. Okay, so that number never changes. I don't care if it's got 1,000 sides. If you have the exterior angles drawn, it's always going to add up to 360. All right, so first here, let's see, we've got a couple of examples. It says find the measure of an interior angle and an exterior angle of each regular polygon. All right, so let's do the interior angle first. This also says they are regular, okay? Which means all the sides are congruent and all the angles are congruent. Okay. All right, so pentagon has 5 sides. So to figure out what each interior angle is, I know again from the previous example that interior angles go with this formula here. So it's again 5 minus 2 times 180, and that was 540. Now each angle is congruent, so there's 5 equal angles in this pentagon that's regular. So I'm just going to divide this by 5 because there's 5 of them. If I do that correctly, each interior angle is 108 degrees. All right, now let's do the exterior angle. Now I know no matter what shape it is, I'm going to take 360 because that's what they add up to, and I'm going to divide it by, in this case, the number of sides it has, which is 5. Okay, if we do that correctly, we get 72 degrees. Another thing I want you to notice is that an interior angle and an exterior angle of any shape are always supplementary. So if we added those together, we should get 180 every time. Okay, let's try another one here. An 18 gon obviously has 18 sides. So let's do the interior angle first. So that's going to be 18 minus 2 times 180 to get the sum of those angles. And if we do that, we get 2,880 degrees. And I'm going to divide that by 18 because there's 18 equal angles. All right. And each interior angle of an 18 gon that's regular is going to be 160 degrees. Okay, the exterior angle is going to be 360. Again, even though it has 18 sides, every exterior angle, if we add those up, is going to be 360. So it's 360 divided by the number of sides, and that's going to give me my exterior angle, which in this case is 20 degrees. And again, notice that the interior and exterior angle are supplementary. All right, that concludes the lesson on the polygon angle sum theorem, how to classify polygons, what's convex, what's concave, what do the interior angles add up to, and what the exterior angles add up to.